Hello, everyone. In this session, we'll talk about regression, and the presenter is, as always, Dr. Sami from the Biostatistics Learning Group. So, regression, if two variables are highly correlated, it is possible to predict the value of one of them, the dependent variable, from the value of the other, the independent variable, by using regression techniques. In a simple linear regression, the value of one variable x is used to predict the value of the other variable y by means of a simple linear mathematical function, the regression equation, which quantifies the straight line relationship between the two variables. This straight line or regression line is actually the same line of best fit to the scattergram as that used in calculating the correlation coefficient. The simple linear regression equation is the same as the equation for any straight line. Expected value of y, which is the dependent variable, equals a, which is a constant known as the intercept constant, because it's the point where the y-axis is intercepted by the regression line. In other words, the value of y when x is 0 plus b multiplied by x. And b is the slope of the regression line and is known as the regression coefficient. We heard the correlation coefficient before, and now we have the regression coefficient, which is B, as in boy. It shows the change in y when x, increases by 1 unit. So B is the slope of the regression line. It is known as the regression coefficient. It shows the change in y when x increases by 1 unit. And x is the value of the variable x, which is our independent variable. So once the values of a and b have been established, a mentioning that it's the intercept, b is the slope, the expected value of y can be predicted for any given value of x. For example, it's been shown that hepatic clearance rate of lidocaine, y, in millimeter per minute per kg can be predicted from the hepatic clearance rate of indocyanine green dye X in milli per minute per kg. According to the equation, Y equals 0.30, which is our intercept plus the slope multiplied by X, thus enabling anesthesiologists to reduce the risk of lidocaine overdosage by testing the clearance of the dye. And it was in a study in 1978. Now comes to other topic known as multiple regression. Multiple regression. Other techniques generate multiple regression equations in which more than one variable is used to predict the expected value of y, which is the independent variable, thus increasing the overall, the y, the dependent, thus increasing the overall percentage of variance in y that can be accounted for. A multiple regression equation is therefore expected value of y equals a, our intercept, plus b1, our slope 1, multiplied by x1 plus b2, slope 2, multiplied by x2 plus etc. For example, a study done by this researcher found that in 2007 found that the risk of hepatic fibrosis, which is why the patient's fibrosis score in patients with NAFLD, which is known as a non-alcoholic fatty liver disease, could be predicted on the basis of the patient's age, body mass index, BMI, presence of diabetes, or impaired fasting glucose, something called AST-ALT ratio, platelet count, and albumin level according to the multiple regression equation, which is y equals our intercept plus slope multiplied by age in years plus this and that. So use of this regression equation was shown to allow a liver biopsy to be avoided in the majority of patients of NAFLD, a disorder that's found in a substantial proportion of Western populations. So multiple regression can be used to search for other potentially confounding contributions to the condition of interest. So multiple regression for confounding variables. If data on multiple other variables are collected, regression techniques would allow their contribution to the left of the equation to be included. If in doing so, the coefficient of the variables of interest change, then the variables have automatically been adjusted for the presence of new and apparently confounding variables. If the coefficient don't change, the new factors have no influence and are not confounders. If the coefficient of any variable approaches zero, it clearly plays no role in the outcome of the interest and can therefore be removed from the equation. And next session, we'll talk about logistic regression. Thank you for your time. And you can follow us on Twitter on the photo that's mentioned here. Thank you so much.